So work done is the product of force applied and displacement in the direction of the force. And someone might wonder why I'm using the word displacement. Remember, you'll be looking at an object probably that is somewhere here. Let's say I have an object here. Assume this is on the ground. This is my ground here. If it happens that maybe there's someone trying to push this, alright. If this person applies a force F in this direction, and it happens that the object moves in this direction and then finally reaches this point, this person has done, the force has done work in moving the object. There's some kind of work done there. So you look at the distance moved in that particular direction. It's probably D there. But since it's distance moved in a specific direction, that's how the displacement comes in, because distance moved in a specific direction is displacement. Alright, so that's work done. But then we need to be very careful, because when the movement is in line, let's say the force is in this direction and also the direction of motion is in that same line, then in this case we say the force is doing work. Force does work. We have situations where the force may be in this direction, and then it happens that the motion, the direction of motion is in this line. Then what it means in this case is that work is done. Work is done on the force. So we must be careful when it comes to issues like this. You see, some of the questions in most cases, they are qualitative, where we need to be able to explain things. There is no calculation, so we must always take note that each time work can be done by the force or work can be done on a force. Alright, let me just get rid of this. Now let's just move on to the idea of calculations, right? So we're saying work done is equal to the product of force times displacement, right? So someone can use S there on displacement, but D with the bar is still fine because it's showing that it's a vector quantity. Right, at lower levels, yes, this formula is very useful, like in a case that I just illustrated up here. But then once you get to A level and moving forward, you realize that you must be careful, because in some cases, for instance, let's say I have my object here. This is an object, right? And then it happens that there is a force acting on this object in that direction, but then the direction of motion is this one, direction of motion. So in this case, you realize that it's not the entire, maybe if this force was 20 newtons, or let me say 15 newtons, right? It's not the entire 15 newton force that is acting on this object, all right? Part of that 15 newton force is the one which is causing motion in a horizontal plane there. So this force might be acting at an angle theta. All right. So what we need to do in cases like this, we have to resolve and find the horizontal component of this force, which is F cos theta. Please ignore the 15 newtons, right? F cos theta, right? This will be the horizontal component, and then we also have the vertical component that will be F sine theta. I hope you did resolution of forces back then, of vectors, right? So now, since the horizontal component is the one that is causing motion, it means the work done now is going to be equal to F cos theta, all right, multiplying the distance moved in that specific direction. So at the end of the day, it means we'll have, so by the way, someone can use S. Remember, we use S to represent a displacement. So this becomes F S cos theta. Right, this will be work done. All right, so that's how we calculate work done in simple terms. All right, and we must be extra careful. All right, so I have just a simple illustration that we may be interested in looking at here. All right, let's assume a man, right, lifts a bag of cement, right? After lifting the bag of cement, he then moves a distance. All right, the question is, does this man do work? Explain your answer. Just think for a moment. All right, you can pause the video and write your solution. Okay, so but then what is important, there are two things here that we need to focus on. Right, let's assume this is our ground, this is the bag of cement, right? In the process of lifting the bag, lifting that bag, work is done against gravity. The man is going to apply a force upward, and the bag is going to move a height of h, distance, that is distance. So what it means is that this man, yes, he does work. Yes, work is done in lifting the bag. All right. Then if he continues to hold the bag in a that position or height h and then starts moving, what it means in that case, in the process of moving, no work is done. No work is done, because what is going on here is that the man is still applying a force trying to hold the bag against gravity, but he is moving in a horizontal motion, right? This will be the direction of motion. So since the direction of motion and the force are now at 90 degrees, then it means there is no work done, right? If we come back to this formula, you realize that